Welcome to Tami's Max. It's miscellaneous. And guess the topic? Of course, it's on the board. Areas. Area is the topic. Area questions. I don't say it's easy, nor do I say tough. All depends on the practice we have and the spark we get when we see the problem. How will you get the spark? Spontaneously. The more and more you practice, you will get the spark spontaneously. Then let's see. Now, the area of the curve x by 5 whole power 2, y by 4 whole power 2 by 3 equal to 1. Some choice is given, 15 pi, 10 pi, 3 pi and none of this. So much of square units. Now, sorry. Some curves you're very familiar with. And maybe every day we read it also. Like conic section we have in a syllabus only. Like parabola, ellipse, hyperbola, rectangular hyperbola. All these things. When we see the equation, we will be able to identify what it is. Circle and areas enclosed by straight lines, many things like that will be very familiar. But some curves we are not very familiar. When we have a question in the exam, we are not going to analyze what sort of curve it is and all that. We are not doing curve tracing here. I want a correct position of the figure and I want the answer to score marks. Okay? I don't tell don't analyze the curve. You can analyze it, but exam is not the place to do that. How do I draw the graphs? When unknown graphs are there, I mean to say not very familiar to you. That's what I mean by saying unknown graphs. I want to find out whether it's spread out in all the quadrants. Like, take this. This is positive. So this will be positive. This won't be spread out in all the quadrants, no. This will be only when x is positive. So only here and here. It will be like this. So here and all you won't have all this. So it's not spread out the entire. That's what I mean. Like that if you have like this. For example like this. This is spread out everywhere. As a circle, it's spread out everywhere. So I want to know whether the graph is spread out in all the 4 quadrants. That's the basic. Or the graph is restricted in some quadrants. First quadrant, second quadrant, something like that. Okay? Now, the area of the curve. This is the curve given to us. X by 5 whole power 2. Y by 4 whole power 2 by 3 equal to 1. Let's check whether it's spread out everywhere. I replace x by minus x and I get the same graph. It is symmetrical about y-axis. I replace y by minus y and I get the same graph. It is symmetrical about the x-axis. Now here, replace x by minus x, you get same. Replace y by minus y, you get same because there is a part 2 here, no? So it is symmetrical about both the axes. That means it is spread out in all the 4 quadrants. It is spread out in all the 4 quadrants. Now, sorry, put x equal to 0. Or you can put y equal to 0 also if you want first. Put y equal to 0. So this is 0. So x is 5 and x is minus 5. So the point we have on the graph is 5, 0. minus 5, 0. Next what is that we are going to have? Next we have, put y equal to 0. We got something. Put x equal to 0. This is 0. Raised to the power of 3 by 2. So, okay. Or you can raise to the power of 3 first. So, y by 4 whole square will be 1 to the power. That's 1. Raised to the power of 3 here. So, y by 4 power 3. So, this is part 2 here. 1 cube, that will be 1. So, y by 4 is 1 or y by 4 is minus 1. So, y is 4 or y is minus 4. So, we will have now y is 4. So, 0, 4 is one point. 0 minus 4 is another point. Okay. Y by 4 whole power 2 by 3 is 1. Raise both sides to the power of 3. So, y by 4 power 2 is 1. So, y by 4 is 1 or y by 4 is minus 1, which gives you that. Now, so we have now, draw a rough sketch. Draw a rough sketch. That is 50 minus 50 0 4 0 minus 4. So like that, it's not an ellipse. Not an ellipse. Something like that you will get. Like that it will be in 4 quadrants. So I find out this area, 4 times that will be your answer. Now let's see what is the area given by. Area is given by, this is integral 0 to 5 y dx. Integral 0 to 5 y dx. Okay. Now, what is y? Y by 4 whole to the power of 2 by 3 is 1 minus x by 5 whole power 2. So, y by 4 is equal to 1 minus x by 5 whole square to the power of 3 by 2. Correct? So, y will be equal to, so now y will be equal to 4 into 1 minus x by 5 whole square to the power of 3 by 2. So now 4 times this, integral y dx, 4 times that will be our answer. 4 times that will be our answer, isn't it? This is only for one particular quadrant I have found out. I am going to find out. Like that 4 times we will have. So this is y. So for one quadrant. This for only one quadrant, like that 4 times we are going to find out. How How am I going to do it? What? X is equal to 5 sine theta. Put x equal to 5 sine theta. Strong you have to be in integration because differential equations, area, all are based on this only. So now 0. Lower limit is 0 for x. So theta will be 0 as a lower limit. Upper limit, x is 5. So sine theta will be 1. So theta will be pi by 2. So what we have now is integral. Lower limit is 0 for theta, upper limit is pi by 2. That 4 is there. This answer should be multiplied with 4. 1 minus x is 5 sine theta. So this 5 and 5 will get cancelled, sine square it will become. Then what is dx? What is dx? 5 cos theta d theta. So dx will be 5 cos theta d theta. That will be dx. So now this is going to be equal to. This will be 1 minus sine square cos square. So cos square, this 2 and this 2 will get cancelled, it will become cos cube. So with this cos, it will become cos power 4. So this will become integral 0 to pi by 2. This 4, this 5, take it outside, 20. Okay? Take it outside, 20. This cos. So this is cos power 4 theta d theta. This is what I have now. Okay, now we will see. 20, 0 to pi by 2 cos power 4 theta. Now cos power 4 theta I will do it separate. Let us consider the integration. Let us consider the integration 0 to pi by 4 cos power 4 theta d theta. Even power of cos. There is no sign with that. So write it like this. Cos square whole square d theta. I am just working this alone. Okay. So now we have 0 to pi by 2. What is cos square? 1 plus cos 2 theta by 2 whole square. So that will become 1 by 4. Correct? So now we will have this as now this will be by 4. Patience is a must. Patience is a very good virtue and it's very much needed in mathematics. A plus b whole square, a square plus 2ab plus b square dt. Correct? So this will be now this will be now 1 by 4. 1 by 4. 0 to pi by 2 d theta. plus of 1 by 4 could be taken outside also like that. 0 to pi by 2 d theta. 1 by 4 is common, so I have it outside. So 2 integral cos 2 theta d theta 0 to pi by 2. So next one will be plus cos square 2 theta, that is integral cos square 2. What is cos square 2 theta? One plus cos 4 theta by 2. So I have taken the 2 outside. This 1 by 4 is outside again. So this is integrated. I think I'll better do it step by step. D theta is theta. 0 to pi by 2 plus 2 times. This is sin 2 theta by 2. 0 to pi by 2 plus half d theta. So that is half 0 to pi by 2. Then cos 4 theta. Half cos 4 theta. So half sin 4 theta by 4. 0 to pi by 2. This 1 by 4 is completely outside. So this will be now look here. This is now. Supply the upper limit pi by 2. Supply the lower limit 0. This 2 and 2 will get cancelled. Supply the upper limit pi by 2. So it is sin pi 0. Lower limit so, excuse me, 0. Now come over here. Half. Upper limit pi by 2, lower limit 0. So it's pi by 2. Come over here. Supply the upper limit. Supply the upper limit. What will happen? Pi by 4, no? So 2 pi. Sin 2 pi will be 0. Supply the lower limit. Sin 0 will be 0. So this is what you have. So this is 1 by 4. Take LCM 4. And this is 2 pi plus pi. 3 pi. Fine. So let's see what we have now. 3 pi by 16. So this is 3 pi by 16. So what is our area? 20 into, the area is 20 into cos power 4 theta d theta 0 to pi by 2. How many times this we want? So 4 times this. So this is 4 into 20 into 3 pi by 16. So here what will happen? 4 and then this will go 5, 15 pi. So it will be 15 pi square units. It's a little different problem because it's not the normal curve we know. So any new curve is there. Don't panic. It's not that all the curves will be knowing. What we are tuned to read like ellipse, hyperbola, rectangular hyperbola, circles and then straight lines, all that we will know. But any new curve comes, please don't panic. Follow whatever instruction I have given. Work it wonderfully well. So the answer here is, carry on. We will meet in the next video, probably with area or something interesting.